All right, guys, interpreting graphs of functions, part 1 is lesson 3. All right. And here we're going to be looking at functions graphically and then interpreting what it means at specific points and doing a little math, and we're going to explain it really well. Okay. So remember that if h of 3 is equal to 2, that means that x is 3 and y is 2. All right. Now, here we have two functions that are being graphed. Okay. So f of x is the dotted line right here. Okay. And g of x is the solid line. Okay. And so the only thing we're doing here is we're just looking at the graph and finding the y values for these x's and doing some math with them, okay? So what is our function of f when x is -1? Okay, so f of x is the yellow dotted line. So x is -1. So right here, at this point, y is 6, okay? Now, what happens when x is -9? Okay, so here we have a hole, all right? Now, if we have a hole, we say it is undefined, all right? Undefined. All right, now let's see when x is 5. We got right here. So it looks like our y is -5, okay? Now, this is asking for our g of x, okay? Our g of x when it's -3.2. So -3.2, so right around in here. So we'll say it's approximately 1.8, I guess. Okay. All right, in the next one, we're looking at the g function, the g of x function when x is -11, y is -2. All right. And the g of x when x is 7, y is -1. Okay. Now, looking at the next one, we have the function of f plus the function of g, okay, when x is 3. So we could rewrite this as the function of 3 plus the function of 3. Okay, so f of 3 and then g of 3. Well, f of 3 is -6 and g of 3 is +6. So the sum is 0. All right. Now, same thing for the next one. We have the function of f at -3 minus the function of g at -3. The function of f at -3 is 6, and the function at -f, or the g of function when x is -3 is 2, so 6 minus 2 is 4. All right. So the next one, we have g of 9 minus f of 9, and it's -3 minus -3, so that gives us 0. All right. Now, on this next one here, we have to multiply the function of f when x is -4 by 2. So we have 2 times 6 minus -2. All right. 2 times 6 is 12. 12 minus -2 is +14. All right. So g -8 is -2, f of 0 is 3, and g of 0 is 4. Okay. So -2 plus 3 is 1, divided by 4. Well, we'll just keep it as 1/4. All right. So here we're multiplying both of the functions, g by -2 and 3, and the function of f by 3. Okay, so we have -2 minus 3, 1. Okay, we get 4 minus 3, which gives us 1. Okay. All right, in the next few examples, okay, we want to find the values of x such that the function of x is equal to a specific y, all right? So here our y is negative 6. So x will be 3, okay? For this point right here, negative 6, 3. And then we want to find the values of x such that the function of x is negative 3. So we have negative 3 here and here. So it looks like when x is 2 and x is 9, all right? And then the last one of this, it says the values of x such that the function of x is equal to 6, okay? So equal to 6. Well, here, okay, we have this interval, all right? This is an interval. So x is when y is from negative 6 to negative 1, okay? When x is negative 6 and negative 1. All right, now looking at the function of g of x, okay? When y is negative 6, okay, we do not have a x value, so we have none, all right? And then when y is negative 3, it's when x is 9. And when y is 4, we have at 2 points when x is 0 and x is positive 4, okay? Now, the next section, or the next part, it says if p of x is equal to x squared plus 2x minus 13, for what values of x is p of x equal to the g function when x is negative 3, okay? So the g of negative 3, the function of g of negative 3 is actually, let's look, when it's negative 3, okay, it's 2. So it's equal to 2. So what we have to do is we have to do x squared plus 2x minus 13 equal to 2, all right? So I'm just going to subtract 2 from both sides, and we get x squared plus 2x minus 15 equal to 0, all right? We could factor. So our back sign is subtraction, so our signs are going to be different. Well, this is positive, so that makes our bigger number positive, all right? What two numbers add to get 2 and what two numbers multiply together to get 3? We have x minus 3 and x plus 5, okay? Set both equal to 0 and we could just solve. So x is equal to 3 or x is equal to negative 5, okay? And then on the next one, we got to do the same thing here, okay? If q of x is equal to 3 times absolute value x minus 3 plus 4, then for what values of x is q of x equal to the function f at when x is equal to 5, all right? Well, when the function's equal to 5, it's actually negative 5. So we have negative 3, absolute value x minus 3 plus 4 equal to negative 5, all right? Subtract 4 from both sides. You get negative 3x minus 3 plus 4. Oh, sorry, we just did that. It's equal to 9, okay? Now we can divide both sides by negative 3. So we have x minus 3 is equal to 3. All right, I'm going to scroll down a little bit to give us some more room. So when we have absolute value signs, to get rid of the absolute value, we make, whatever it's equal to, positive or negative, okay? So we have x minus 3 is equal to 3, or x minus 3 is equal to negative 3, okay? So solving for x is 6, or x is 0. All right. When handed a 3-page story and asked to read it, where do you begin? When you read a graph in mathematics, the same is true, okay? The graph is read from left to right. So here we have a few examples of decreasing, increasing, and constant intervals. All right, and we're going to break it down and establish which one is which, okay? So at the first one, we want to look for the part of the function where it is decreasing, okay? So here we have two intervals, so this interval and this interval, all right? And then it asks us to identify what intervals are decreasing, okay? So it is from -5 to -3, and from 4 to 6, okay? That is the two intervals where it is decreasing, all right? Now looking at where this function is increasing. Here we only have one interval, okay? Only one interval where this function is increasing, and the interval is from -3 to 0, and it is when x is bounded between -3 and 0, okay? And then when it's constant, all right, we just have one interval again as well, and it is right here. And the interval is when x is 0 to 4. And so we could say x is bounded between 0 and 4, okay? Now, should your intervals identified above be identified as closed intervals? Example, use of brackets, or open intervals, example, use of parentheses. Give a reason of choice, okay? So the intervals should all be open intervals, okay? So parentheses, because the endpoints of the intervals the graph is not increasing, decreasing, or constant. All right. Rather, the graph is changing constantly. All right. So it's open interval because the function is decreasing, then it's increasing, then it's constant, then it is decreasing again. So that is why we use the open interval. Now identifying the domain and range. Okay, the domain of the function is -5, 6, and the range is -3, 5. Okay, we're using closed brackets for every single piece. All right. All right, comparing function values to 0, which variable x or y does the function notation f of x represent? Okay, that is on the y values. If f of x is equal to 0 for a given point on a graph, then where is that point located? Okay, it is on the x-axis, okay? If f of x is greater than 0 for a given point on a graph, then where is the point located? So it's above the x-axis. So y is positive here, okay? Y is positive. Now, if f of x is less than 0, so y is negative for a given point on a graph, then where is that point located? Well, it is below the x-axis because y is in fact negative. Now, we're going to use, I'm just going to use red here, and we're going to identify when f of x is equal to 0, when f of x is greater than 0, and then when f of x is less than 0, okay? We're going to do the highlighting marking first, and then we will write the intervals, okay? So when f of x is equal to 0, okay, should be 3 specific points. So here, here, and here. And then when f of x is greater than 0, okay, greater than 0, so it's increasing, then it's decreasing, then it's increasing again, then it's constant, and then it is decreasing, okay? So this red marking, it is all when y is positive, okay? And now when y is negative, when f of x is less than 0, we have it increasing and then decreasing right here over the intervals, all right? Now, identify the x values for the highlighted portion of the graph, okay? This is 3 specific points, so we don't have intervals, so x is -3, 0, and 6, okay? Here we do have an interval, and it's from when we have -3 to 0, and then our 0 to 6. The reason why we have an and is because when x is 0, y is 0, all right? And then last but not least, we have -5 to -3 and 6 to 7. All right. Again, should your intervals identified above be identified as closed intervals or open intervals, give a reason of your choice, okay? So the intervals might open, closed, or mix depending on what is being identified by the interval and where the graph is located at the endpoints, okay? Now, that is why when f of x is less than 0, we have brackets, because at -5 our graph starts and at 7 our graph ends, okay? That's why we have brackets. Now, to identify the domain and range, the domain is -5, 7, and our range is -4 to +4, okay? The last page, all right, this is a free response, all right? This is for you and your practice. It'll help you with your homework, so get started on it. Ask me any questions if you have. Now, if you're confused on any of the notes, when you come back to school, come see me and come ask questions, all right?